Welcome to this explainer. Look, we've got to talk about a massive, fundamental shift happening literally right now in how we write, think about, and interact with code. We're officially entering an era where, well, you're no longer programming alone.
Right off the bat, let's just address the elephant in the room, shall we? Because if an AI can spit out hundreds of lines of perfectly formatted code in a matter of seconds, what actually happens to human skill? Are we basically programming ourselves out of a job? You know, it's a completely terrifying question, but the answer is actually incredibly exciting. That is, if you know how to adapt.
So to understand why human skill is honestly more vital than ever, we need to get our definitions straight. AI pair programming absolutely does not mean the human does nothing. Instead, think of it as a totally collaborative co-pilot dynamic. You, the human, remain firmly in the pilot seat. You're setting the context, reviewing the options, and making the final call. In the AI, well, it's basically your hyperactive co-pilot, suggesting code snippets, explaining cryptic error messages, and even writing out your tests.
All right, so here's our roadmap for this explainer. We're going to cover the new tool set, understanding overcopying, building your safety net, hidden dangers, real-world impact, and finally, the future of coding. Let's dive in.
Section 1. The new tool set. We're shifting from typing fast to communicating precisely. Because let's face it, coding is no longer just about memorizing syntax or being the fastest typist in the room. It's fundamentally transforming into a discipline of precise communication. The old way of getting help was basically just a vague wish. Imagine throwing a bad prompt at an AI, something like, program me a game. That just gives the AI way too much interpretive freedom, and it usually spits out a bloated, unusable mess, right? But a good prompt, that acts as a precise technical blueprint. You state your language, say Python, your library, Pygame, and crucially, you constrain the AI. You tell it to explain the steps first before it gives you any movement logic code. See, you aren't just offloading the work, you're actually structuring the workflow.
Moving on to Section 2, understanding overcopying. Let's talk about the danger of taking shortcuts.
Because, look, once you generate that code, there is this massive temptation to just hit copy and paste and call it a day. But anyone who uses AI merely as a giant copy-paste machine isn't really learning. Actually, scratch that. They're not learning at all. They're just accumulating technical debt and a whole lot of risk. So to combat this, we use what we call the explanation loop. It's this absolutely crucial workflow that turns the AI from a simple answer machine into an active thinking partner. First, you describe your goal. Then you generate the suggestion, but then, and this is step 3, the vital one, you demand an explanation. You actively ask the AI, hey, why did you choose this data structure? Or what are the edge cases here? And only after you run tests do you refine and move forward. And this whole loop brilliantly illustrates a massive psychological trap, the illusion of competence. It's that totally false feeling of mastering a skill simply because an AI system pumped out a polished, finished result for you. I mean, ask yourself this. If the AI confidently handed you a beautifully formatted but fundamentally flawed piece of logic, would you actually have the core knowledge to catch it? Or are you just operating under the illusion that you know what you're doing?
Which brings us to Section 3, the safety net. How do we go about catching our co-pilot's mistakes?
Well, first, we have to remember that AI models are probabilistic, right? They're just predicting the next most likely token. They are definitely not truth machines. So how do we catch those inevitable mistakes? We build a safety net. The absolute key here is adopting what's known as the stop rule. You literally never proceed to the next step of a project until the current AI-generated code is fully understood and fully verified by tests. Developing an active error culture where writing unit tests and integration tests is the very first thing you do, that's no longer just a chore. It's the essential safety net of modern programming.
Now for Section 4, hidden dangers, the perils of blind trust in real-world applications.
And trust me, you absolutely need that safety net because the risks out there are very, very real. When we blindly trust AI code in real-world apps, things can go wrong incredibly fast and at a massive scale. We're talking about bad actors using prompt injection attacks to completely manipulate the AI's behavior. Then we've got plausible hallucinations, where the AI literally invents software libraries that do not exist, but it makes them sound totally legitimate. Add to that unsafe output processing, potential copyright conflicts hiding in the AI's training data, and huge privacy leaks if you accidentally paste sensitive user data or proprietary code right into an open prompt. Remember, the AI system lacks professional liability. It literally doesn't care if your company gets sued.
Which brings us to the professional core of this entire explainer.
Responsibility cannot be delegated to the tool. It's a simple statement, but wow, is it profound. Think about it. If a piece of AI-generated code leaks customer data, you can't exactly take the AI to court. The human developer, always and forever, owns the consequences of the code they push to production.
All right, Section 5, Real-World Impact. How this plays out from middle schools to corporate enterprises.
So, how does this paradigm shift actually hit our day-to-day institutions? Let's pivot for a second and look at two very different environments trying to navigate this whole thing, education and the corporate world. The stakes in both are vastly different but equally complex. In schools, the major challenge is evaluating the learning process itself. Educators have to somehow ensure fairness and figure out how a student can prove independent thought when an AI can literally do their homework in 2 seconds. Meanwhile, over in enterprise tech teams, the focus is entirely on legal liability, enforcing super strict security policies, and making sure the AI doesn't just shatter complex pre-existing legacy code. Basically, students must prove their cognitive process, while professionals must protect their products.
And what's genuinely fascinating is how this completely breaks down the way we evaluate success across the board. In the old way, the focus was almost entirely on the final product, right? But now, in the new way, it's all about the process and transparency. Testing used to be this secondary afterthought. Now, it's your core safety net. And the main skill required? It has totally shifted from just syntax memorization to critical review. So educators and managers alike have to completely reevaluate what a successful coding project even looks like today.
This leads us to our final section, Section 6, the future of coding. What human skill looks like moving forward.
And we're in the home stretch of our explainer here. If AI is handling all the heavy lifting of writing that boilerplate code, what exactly is the human's job? Well, here is your core takeaway. We are witnessing a massive shift from syntax to judgment. Basic syntax knowledge is kind of stepping back into the passenger seat. Instead, critical judgment, system-level architecture, logical reasoning, and steering that automated logic, those are taking the wheel. Simply put, you are no longer just a code typer, you are a director.
So, I want to leave you with this thought to help evaluate your own digital maturity right now. As AI becomes an everyday, totally normal part of our workflows, are you ready to step up, set the rules, build those safety nets, and truly be the pilot? Or will you just sit back, copy and paste, and become a passenger to your AI copilot? The choice of how you learn and work from this day forward is entirely up to you. Thanks so much for joining me on this explainer, and keep learning.